Gravity and Simple Harmonic Motion Review 7. All right, you can't quite see the figure yet, but you will be able to here in just a minute. And that figure is going to depict a wall and a frictionless surface. Although not shown in the figure, assume a spring connects the wall and the mass, which oscillates between the two tick marks shown below the surface. Fill in each of the 18 white boxes to show the value of each quantity at that location. And here are the choices for us to put into the boxes. What we have here is we have a wall on the right side, and we have to imagine that there's a spring connected to it, which is attached to a mass. And that mass is at an equilibrium position right here where my pen is pointing at the bottom of the screen. And then our mass oscillates between this tick mark on the left and this tick mark on the right, back and forth, back and forth. And we want to state what the values of all these different things are at these different points. It doesn't matter where we start. Why don't we start at the equilibrium position? At the equilibrium position, the spring isn't going to be stretched. So the force in the spring is going to be 0. And the force in the spring is the net force because the weight and the normal force exactly cancel. So the net force, since there's no friction, is equal to the elastic force. And if the net force is 0, then the acceleration is equal to 0. The position x at equilibrium is defined as being 0. And if there's no stretch in the spring, then there's not going to be any elastic potential energy when we're at that location. And if u is 0 there, then k must be a maximum. Always a positive number. So we have to make this choice up here that I'm pointing to with my pen positive maximum. We can't say maybe positive, maybe negative, and it's a maximum. We have to choose the positive one. The v, on the other hand, that's velocity. And so this mass could be moving to the right at equilibrium, or in some cases it's going to be moving to the left because it's going back and forth. So the best answer for the velocity is, it could be positive or it could be negative, but it's a maximum number there. So far, so good. Now, what about the extreme points? We are told that to the right is positive down here at the bottom of the screen. So that means that when we're at this extreme point, this is going to be a positive maximum, which means over here we're going to have a negative maximum. At the extreme points, we know that the velocities are going to be 0, so we can put those in. The acceleration is going to be a maximum value, and when we're at this location here, the displacement is positive, but the net force is going to be in the other direction. It's going to be in the negative direction. So this A right here is going to be a negative maximum. On the other hand, when we're at this point, there's going to be a net force on the mass to the right, which is in the positive direction. So this one, shouldn't it say that that's a positive maximum? Since the force acts to the right, that's going to be a positive maximum. Over here, the force will be acting to the left, which means that's going to be a negative maximum at that extreme point. Since the velocity is 0, the kinetic energy will also be 0 at both of the extreme points. And the potential energy will be a maximum. And what's the equation for potential energy? Shall I write it right up here? Do you remember this? It's 1/2 kx squared. So whether x is positive or whether x is negative, in the case of a spring, you can see that by that equation, the potential energy is always going to come out positive. So we do have to say here positive maximum and positive maximum for that one.